Hello y'all, welcome to this session. I am Anderson Castellon. I am a certified full-stack Sitecore developer. Currently, I am at JDK Standing Technologies, where I contribute to innovative projects for our customers. This is the first video in the Sitecore and Docker video series, where we will learn all the important details about running Sitecore in Docker containers. In this video, we will provide a brief introduction to Docker and the key concepts related to this containerization tool. We will also cover all the necessary requirements to run a Sitecore instance in Docker containers, the currently supported Sitecore topologies, and a concise list of the Sitecore images needed to run a specific topology. Specifically, we will focus on the Sitecore XP workstation topology for the development workstations. Let's begin by discussing Docker, the tool we will use to run our entire Sitecore instance. Docker is a platform for developers and sysadmins to develop, deploy, and run applications with containers. In simple words, Docker is a containerization platform that packages your application and all its dependencies together in the form of containers to ensure that your application works seamlessly in any environment. Containers allow us to package all the things that our application needs, such as libraries and other dependencies, and ship it all as a single package. In this way, our application can be run on any machine and have the same behavior. A Docker file is like a recipe book for building a Docker image. It's just a plain text file that tells Docker what ingredients to use and how to put them together. In this file, we list things like what kind of operating system the container will use, what programming languages it needs, where files should go, and what it should do when we start it up. It's like giving instructions to build a tiny, self-contained computer that knows exactly what it's supposed to do. A Docker image is like a complete package for running an app in a container. It's got everything the app needs inside it, like the actual code, tools, and other stuff it relies on. When you start up the Docker image, it turns into one or more copies of the container, each running the app. It's kind of like making copies of a recipe to cook the same dish multiple times. A Docker container is like a living version of a Docker image. It's what actually runs the app. You can have lots of containers all made from the same image, each one running the same app. It's like serving the same dish at different tables in a restaurant. Containers are lightweight because they don't need their own operating system to start up. They are just small, independent processes that run on the host machine. This means they don't have a lot of memory or other resources, making them efficient and easy to manage. A Docker registry is where images are saved. It can be yours or shared, like Docker Hub for teamwork. Sitecore registry is at scr.sitecore.com. It's a handy place for storing and accessing Sitecore-related Docker images, making development and deployment easier for Sitecore users. Docker Compose simplifies running several containers together as one service. It does this by running each container separately but lets them communicate. You set up your application services using a YAML file with Docker Compose. It helps manage complex setups of multiple containers, handling their startup and configuration smoothly. Docker Compose is a solution to the challenge of orchestrating and coordinating various containers efficiently. Additionally, it supports all properties defined using the Docker run command in PowerShell terminal, for example. In conclusion, Docker provides efficiency and flexibility by packaging applications with their dependencies, ensuring consistent behavior across different environments. Now, let's talk about the requirements needed to run Sitecore on Docker on our computer. There are hardware, software, and network requirements. Let's examine them in details now. The hardware requirements that need to be met are 32 GB of RAM, a CPU quad-core or higher, 40 GB free disk space, virtualization support turned on in the BIOS. The software requirements that need to be met are Windows 10 version 1909 or later, or Windows 11 Professional or Enterprise Edition. Enable Hyper-V, Docker Desktop for Windows, and of course, a Sitecore license file. And finally, we have the network requirements that need to be met because in Docker, we require the use of network ports that allow communication from within the containers to the outside world. For a Sitecore instance, we need at least the following network ports available. The port 443 is used by traffic, enabling connections under the HTTPS protocol. Basically, we will access our Sitecore instance throughout this port, ensuring a secure connection. Port A079 is also required by traffic, allowing access to its dashboard. Port A984 is necessary for the Solar server, while port 14330 enables connection to the SQL Server database using SQL Server Management Studio. To validate if a port is in use, you can execute the following command in an Elevate PowerShell window. Let me open my PowerShell. Okay, the command is get process -d get net TCP connection local port. Next, we need to write the port that we want to verify if it's in use or not. And lastly, we need to add point owning process. If you receive a result containing the process ID, like in this example in my Windows PowerShell, it means the port is in use. However, for example, you encounter an error message. For example, let me try another port. If you encounter an error message such as this, it indicates that the port is not being used by any process. Let's continue with the presentation. And now that we know all the necessary basic requirements, let's explore the Sitecore topologies that are officially supported to run on Docker containers. In simple terms, a Sitecore topology refers to the setup of different components like servers and databases that work together to run a Sitecore environment. We can refer to these components as Sitecore roles. Let's begin by learning about the first Sitecore topology available to us. This is the first Sitecore topology, the Sitecore Experience Platform Workstation for Docker. Topology, also known as XP0, is for developers' workstation environments only. This topology is designed to reduce memory overhead, reduce download size, improve startup, shutdown times, and reduce complexity. All Sitecore roles belong to a role type. The production role type is for images that can be used in both production and development environments. The non-production role type lists Docker images that can only be used in development environments. The Sitecore Experience Manager server for Docker topology, also known as XM1, is suitable for use in both production and non-production environments. And the Sitecore Experience Platform server for Docker topology, also known as XP1, is suitable for use in both production and non-production environments as well. The resources required to run the XP1 topology in a non-production environment can be significant but are required to mimic the exact configuration that is used in production environments. In non-production environments, it is best practice to use a workstation that meets the minimum workstation hardware requirements. We are almost done with the basic theory needed to better understand and manage a Sitecore instance running on Docker. Now, let's delve into how the Docker images we will need are named, as well as the tagging strategy used to identify the different versions available for use. Understanding this part is crucial to avoid conflicts caused by using incompatible versions in the Sitecore topology we are running. Sitecore uses different naming roles for its images. Some images, like modules, are only for building your custom Sitecore image, not for running. These are asset images, and these are named with an asset suffix. Examples include Sitecore SBE assets, Sitecore Management Services XM1 assets, SXA XP1 assets. You can see the suffix at the end of the name of the image. Also, for topologies, some images are tied to a specific one. For example, XP0, XP1, or XM1. If the name doesn't mention a topology, it's not tied to one. For example, Sitecore XP0 CM is a Docker image only for use in the XP0 topology. The Sitecore XP1 Cortex reporting, and the JSS XM1 assets. This is an asset images that only can be used in the XM1 topology. Sitecore images are tagged using a system with 3 parts: a full tag, a 3-digit tag, and a 2-digit tag. Typically, the first part of the tag shows the Sitecore or modules version, while the rest gives details about the base Microsoft image it's built on. Sitecore avoids using latest tags because they are too ambiguous and aren't typically supported by Microsoft or other OS-based images. Platform images encompass base images for the Sitecore Experience platform. The initial part of the tag corresponds to the Sitecore platform version. Modules and Tools category covers images like modules for the Sitecore Experience platform and also general tools. Modules and tools may not always match the platform's versions. In cases where a module or tool doesn't align with the platform version, a compatibility matrix is available in the Sitecore knowledge base. The full tag looks you to a specific image version. The 3-digit and 2-digit tags offer more flexibility, letting you get the latest image version. You only fix the main version while allowing the rest to update to the latest. Choosing between the full tag and shorter tags depends on your building and releasing process and how much control you need over the image version. For instance, you might use a short tag during development and switch to the full tag for the deployment. You might use a short tag during development and switch to the full tag for deployment. If you always want the newest image, stick with a short tag. Since Sitecore maintains containers and their unchangeable images, it's best to use the 2-digit tag when making container images. This ensures you have the most recent Sitecore container and automatically receive the latest updates. We are nearly done with this theoretical introduction to using Sitecore with Docker. For now, we are focusing on Docker and Sitecore in development environments. Next, we will explore the images available for each role in the XP workstation topology. What follows is a list of URLs pointing to the images we will use later to take our first practical steps into the world of Sitecore with Docker. So let's see what these images are. The structure of each table is simple. In the header, we can see the Sitecore role. Then we have two groups. The first one is for Sitecore version 10.2 and the second one is for version 10.3. In April of this year, 2024, Sitecore version 10.4 was released, and of course, Docker images are available even if they are not listed here. In each group, we can find up to URLs. The difference between these is the OS version, LTSC 2019 or LTSC 2022. Remember that the preferred approach is to use the same OS version for all Sitecore roles within the Sitecore topology. The meaning of LTSC in the OS version is long-term servicing channel, which refers to versions of Windows Server that receive feature updates every 2 or 3 years. Therefore, we can infer that images with the OS version LTSC 2022 received updates 2 years ago. This results in more stable images free of errors due to constant updates. We can break down the structure of each URL to better understand its composition and the naming conventions applied. For instance, the first segment is the Sitecore registry domain. The second segment contains all Sitecore Experience platform image repositories. primary platform repositories are located at the root, and we can find images specifically for development and testing under SXP non-production. Finally, we have the image name and its version separated by a colon. As mentioned earlier, some images do not belong to any specific topology but can be used in all topologies. For example, the Sitecore Identity Server image, unlike, for instance, the Sitecore Contents Management image, which is indeed part of the XP Workstation topology. As I mentioned at the beginning, we are focusing on the XP Workstation topology. So these are the available images for running Sitecore within Docker in a development environment. The images for Microsoft SQL Server and Apache Solr used in the XP0 topology are only for development and testing purposes. They can also be used in other topologies in development environments. The image for traffic reverse proxy is not stored in the Sitecore registry. Instead, we obtain it from Docker Hub and we can use it for both versions of Sitecore. Last but not least, you will find this presentation below this video so you can study it more closely. You will also have access to this list of references where you can find more relevant information about Sitecore and Docker. That's all for this video. If you watch until now, it means you are starting your journey with Sitecore and Docker and you want to include it in your development process. At JDK, we are constantly innovating, optimizing our processes, and adopting best practices in Sitecore development to deliver the best experience to our clients to a highly skilled and experienced team. Please leave your comments and questions below this video and don't forget to subscribe to this channel to continue learning about Sitecore. My name is Anderson and see you in the next video. Bye bye.